All right, let's begin. How to deploy data analytics workloads in the cloud, actually, because as you all know, DataMinded mostly does cloud analytics. It's a webinar today. We're the 30th of July, if I'm not mistaken. Before we dive into the content itself, let me first introduce myself and my co-host. So I'm Kris Peeters. I'm the founder and CEO at DataMinded. And in my days, I've deployed quite a few analytics projects already over various different cloud environments. Stijn, can you also introduce yourself?
Yeah, so I'm Stijn de Haes. I'm a lead data engineer at DataMinded. And I've been building data platforms and microservices platforms in the last 3 years. So I've done a lot of deploying and automating the deploys of data products. Yeah.
Right, cool. A few slides about DataMinded itself, so you know us a bit better, you get to know us a bit better. So we're now about 6 years old, almost 6, I think, and we've built a strong record in building data analytics solutions across enterprise clients, government clients, and startups. By the way, I think some of these people are in the call here, so you might recognize your own logo. But we're not here to talk about any specific client. We're here to talk about deployments, of course. And one thing that we're really proud of is that DataMinded, we're not just reselling AWS services or just reselling Azure services or reselling Google services. We're a partner of all 3 clouds. We're an advanced consulting partner of Amazon, I think one of the only ones in Belgium. We're a Microsoft Gold partner, and we're also a Google partner. And we're very proud of being partner of all 3 of those because we want to help the customer first, and then, and as a secondary step, look at how cloud can help them. We're not here to push whatever the latest and greatest technology that they release, right? We're here to help our clients. Another thing of DataMinded, or another big step for us, is that we recently released Datafy. Datafy is a tool that helps you accelerate your data product development. It's actually a managed analytics platform for building secure, scalable, and reliable data products in collaborative environments. We're going to show a little bit about the lessons learned of deploying use cases, deploying analytics, how we apply those lessons learned to Datafy. But if you want to know more, you can always visit the website, get.datafy.cloud. That being said, let's dive in. Maybe, Stijn, I leave the floor to you. And let's dive into how to actually deploy your data analytics workloads. Stijn?
Yes, I needed to unmute myself, of course.
All right. That's cool.
The most bright people in the world tend to do this. So today we're going to talk about deploying your analytics workload. And why are we doing that? Well, deployments is like one of the most important things you do, or is even the most important thing you do. Because if you don't deploy your code at a certain point, you will never have impact. So you need to deploy your code into production. Otherwise, you're just playing around in a sandbox. We also think you should aim to deploy 10 times a day. Why? The more often you deploy, the faster you can learn from either your mistakes or your customer's behavior. And the faster you can iterate and change the direction of your company if needed. If you go for this aim of 10 deploys a day, you also tend to automate a lot. And automation is good because it means you have more time to do other things. And third, we also prefer off-the-shelf frameworks and PaaS APIs. So first use these, and then if you know the limitations, you can build something that fixes those limitations. But also you should first deploy something and make money before you have a budget to build something yourself. So we believe in shipping something as fast as possible using what's available. So then you can learn from your 10 deploys a day. You can learn what is wrong with your operations, and maybe you can build something that works better for you. But start with what is available already.
Yeah.
So the problem we are solving is we've just coded everything. It works on my machine, but my machine is a MacBook. In the cloud, I can't run stuff on MacBooks, so I can't ship my MacBook to the cloud. That's also not an option. So I want my code, I want to package it somehow and ship it to the cloud so it can run over there, or an on-prem solution. If you go to the next slide, we have some pictures on. No, we have a second thing. Your algorithm also needs to run all the time. So it's becoming more and more important with algorithms that they typically retrain themselves on new data to learn new things. So that's for ML algorithms. But also you want the latest data on your customers, for example, to know what is important to them and to learn from them. That means that you need to be able to run your scripts that you wrote or your data algorithms. You need to be able to run them every day, every hour, sometimes even real time, so you can directly react on events on your customers. So it's becoming more and more important to keep up to date and keep everything green and monitor and measure it.
Maybe one thing I can add to that is there is an exception here. We see some analytics where the deliverable of your analytics project is a PowerPoint presentation, right? Where you gather some data, you find some insights, and you present those insights to leadership or to whoever, and they make a decision based on those insights. And those can be very valuable analytics projects, don't get us wrong. But if you have that situation, then you don't really have a deployment problem because you don't need to deploy anything. You can just run it on your laptop, copy paste to PowerPoint, and be done with it. But this webinar is about those cases where just copy pasting to PowerPoint is not a feasible option for you.
So let's talk about what a deployment is. A deployment is giving a developer coffee and waiting until he shit out some code, or make some code, of course, and then packages it up in a box, apparently, according to this diagram. No, so yeah, you have your developer making code, and that code needs to be packaged and shipped somewhere. And then that package that needs to be deployed. So today we'll be talking about, sometimes we'll be talking about that package, but mostly about the deployment after it. That package can be several things, by the way. And so we believe indeed that deployments are the most important thing you do. Your code isn't finished at the point that the test run and you've put it in Git. No, it's only finished when it runs in production and it's successful and it delivers value.
Yeah, indeed. And maybe I want to stress there, it's really important because we as engineers, we can sometimes get stuck into very focused on our own tools and our own algorithms and how we build things. And sometimes it's really important to realize that whatever you do before you deploy actual code to actual customers, right, is also not good enough to deploy it to like your UAT environment. But everything you do before your customers get access to your code, everything you do there is work in progress. It cannot, like by definition, create any value. So that's all super nice what you do there, but it's only when you ship it to your customers that you will actually potentially create value. And that's why we stress it's such an important thing to do.
Yeah, and we also believe the worst thing you can do is once you've finished your code, start on the next thing while not deploying your current code, because that means you will have 10 or 20 things in production after a while.
Yeah.
And it will be very hard to follow up. If you then deploy these 10, 20 things to production, it will be very hard to follow up which of these exact commits have introduced maybe a bug in production.
Indeed.
So we're also often inspired by this book, The Phoenix Project, which I will recommend you to read. It's a novel about IT, DevOps, and helping your business win. But it's actually a story about an IT manager that gets promoted very heavily in the company, and he has to solve all kinds of problems. It's very interesting. You will have a lot of aha moments where you think, this also happened to me. But one of the messages they give is aim for 10 deploys a day. If you start thinking about what you need to do 10 deploys a day, and with 10 deploys a day, we don't mean across your company, we mean in a team. So your team should be able to do 10 deploys a day. You'll be thinking about what you need to do to make this possible, and you'll notice that after a while, you'll be automating so much that you don't even think about it. Every commit can go after some unit tests, integration tests, maybe straight to production.
Yeah, indeed. And by the way, this looks more easier than it is. We know plenty of companies who still can't even deploy once every 2 weeks. And then honestly, despite all the name calling or the buzzwords they use internally, if you cannot deploy new features to your customers every 2 weeks, then are you really agile? If you're really being honest with yourself, you're probably in some kind of waterfall project then, right? Because you can only learn from your customer maybe every month or every quarter. And you can't really, in an agile way, adapt to the feedback of your customer. So really, if you're in this mode of deploying once every quarter, try to see what can I do to deploy once every month. If you're there once every month, what can I do to go to 2 weeks, to 1 week, and so forth and so forth. And it's an ongoing battle, I would say. Yeah.
It also becomes progressively harder.
Yeah.
It's very easy to release every 2 weeks. Then going to every day becomes a lot harder, because if you release every 2 weeks, you can spend a day of testing, for example. If you do release every day, you can't do that anymore. So you need more automation.
Yeah, indeed. So maybe that was a bit about what is the importance of deployments and what are deployments actually, and why do we do deployments and how do we look at deployments? But that's all easy to say, but how do you actually do it? And in the recommendations we give here, we focus on analytics workloads, right? So if you're in a web app development world, probably some of these recommendations apply as well, but these recommendations are focused to what we see that works at clients and what we see that clients are also struggling with. So what are your options actually? If you think about deployments, you can evaluate the deployment method on two axes. One is obviously the effectiveness. So how good will your deployment be? Are there limitations to what you can deploy with your deployment method? Maybe there's a limitation in the file size that you can handle or something like that. How often can you do deploys? Do you have a deployment mechanism that really is only feasible to do once a week because it's so cumbersome and so manual? Or is it something that you can do 100 times a day? And also, obviously, it's nice that you can do it and that you can also do it often, but how high quality are the deployments that you do? So will the deployments be stable? Will they be easy to monitor, et cetera, et cetera? That's one axis to evaluate the deployment. There's another axis that we call feasibility. And that is basically asking yourself the question, how easy is it to get started with this? So if you think about energy, for instance, probably like the most effective way to produce energy is through nuclear fusion or something. I'm not a physicist, so what do I know? But nuclear fusion is actually really hard to do. So it might be very effective, but not really feasible for mere mortals, right? It's the same is true on a much smaller scale for analytics deployments. There might be some very cool deployment mechanisms out there, but you as a data team, do you have to learn new technologies to adopt them? Or you have to spend a lot of time building that? Because if you have to tell your business like, hey, we need to spend the next 6 months building our deployment pipeline, I'm not really sure if you can convince them of that. And also, like, can you use it for multiple purposes? Or is like, oh, no, this processing framework needs this deployment and we need to spend 3 months on this one. And then this deployment framework or this technology needs another deployment framework and we need to spend another 5 months on that one. So these are the two axes on which we evaluated the deployment mechanisms we see in the wild. And so obviously we're consultants, and consultants always put things on a 2x2 matrix. We did that as well. I mean, some cliches are useful. This is a typical cliche of consultants to make a 2x2 matrix. But so if you put on the x-axis the feasibility and on the y-axis the effectiveness of a deployment, then you get 4 quadrants. And here on the bottom left, you begin with things that are not very feasible for your team, and it's also not very effective. Obviously, those kind of deployment mechanisms you need to avoid at all costs, migrate away from those because they will be painful and there will not be a lot of value add in those deployments. Secondly, on the bottom right, those are things that are very feasible. So yes, almost everybody can do them, no worries, but they're not very effective. So you'll get a lot of issues, you'll get a lot of stability issues, you get a lot of monitoring issues with that deployment. And after a few weeks or a few months, you start hating yourself for having to keep that system live, right? So those things we believe are good for MVPs or for demos, but not for real life production use cases. Next on the top left, you have the reverse of that, like deployments that are very effective that we see, look, if you do this well, you're going to be successful, it's going to be good, everybody's going to be happy, but those things are actually really hard to do, so the feasibility is low. I'm going to discuss those as well. And then finally, what we've seen the most success with are deployments that are both feasible for an average or typical data team and also very effective in how they do deployments. That doesn't mean that if you use those technologies or those techniques that it will always be perfect. I mean, you can still write bugs. But we've seen this at clients being adopted and being very successful with those techniques. We're going to plot out the techniques here, but then we're going to go on each of those techniques. We're going to deep dive into a separate slide. So don't worry if you don't get all the buzzwords on this slide. First off, we think deploying to pet VMs is one of those things that you should migrate away from very soon. It still happens. We still see it at a lot of companies. So we're going to discuss a bit what we mean by that later. Finally, another two mechanisms we see is you just run on your laptop and you copy the insights to a production server. That's a technique we see. We also see a lot of use of notebook sandboxes. So they just hack around in a notebook, and once it's done, they schedule it and done. Those are techniques that are very feasible. They're relatively easy to do, but they cause a lot of pain down the road. So we typically say that's good enough for demos of MVPs, but move away from that as you mature. Now, on the other quadrant, what I said, it was hard to do, but very effective. We see three patterns coming back. One is cattle VMs, and Stijn will explain what it is. Second is automated notebooks. A lot of people see the constraints of their notebooks and they try to automate a lot of it away. But that comes with its own complexity, of course. And then one other technique that we see a lot is Docker and Kubernetes. We're a big fan of Docker. We're a big fan of Kubernetes. We use it at a lot of our clients. But we do feel like the feasibility of that thing, the complexity that it brings, you shouldn't be underestimated. And then finally, where we see most success is that if you use containers or jars in combination with the PaaS APIs that just come from your cloud provider. So the cloud providers have a lot of platforms as a service that offer an API out of the box. It's very easy to deploy workloads to those things. And finally, there are also some cloud-independent off-the-shelf frameworks that are really good and really help you accelerate deploying things to the cloud. So that might still be a bit vague. Let's dive into each of these options one by one. What do we mean by deploying to a pet VM? As we say, we would consider that low feasibility, low effectiveness. But a pet VM is very simple, a machine that you name and you really care about. It's precious to you, and you manually make sure that it stays alive. A real-life example of that is what we see a lot, for instance, is you have PhD researchers, they've done their PhD in MATLAB, and now they build a company around it, and they want to industrialize their algorithm, but they keep their algorithm in MATLAB. And MATLAB typically runs on this very precious pet VM that you need to keep alive all the time, and it very quickly becomes a bottleneck in your end-to-end architecture. What's good about this is that it's probably a technology you know, otherwise you wouldn't choose this. And sometimes it's also the only option. I remember sometimes we had those discussions like, why don't you replace MATLAB with Python or with whatever you like, right? But with something that you can easily package and deploy. And they say, well, but there are algorithms available in MATLAB that we can't have in Python. Hard for me to judge if that's true. Maybe it is. So you're kind of stuck with it, right? What are the cons to this? Is that obviously these pets, they have a very high yearly license fee most often. Maintaining a pet costs you a lot of time. People underestimate that the amount of engineering time that goes into maintaining a pet, making sure it's upgraded, it's patched, it's security proof, it crashed, now you need to bring it up again. Deployments are very manual, very error prone, because it's very hard to automate these things. And it's also, when it goes south, we've seen teams struggling very hard to recover when it goes down, right? So we see sometimes it's a necessary evil to have in your architecture, but when you identify these pet VMs, like as soon as possible, focus on why they're there, try to migrate away from them in one way or another, right? Challenge them from day one, I would say. Next, we move to
You had a question in the chat.
Okay, sorry.
You had a question from Quinton. Wasn't DataCamp one of the first to allow R compilation services at scale?
I don't know about that, to be honest. I think DataCamp, again, I don't know, but DataCamp is they provide courses, so I wouldn't know if they do R compilation at scale, if they would be the first ones to do it. I think if you wrap your R script in a Docker container, you can do R compilation at scale as well. Is that the question?
Yeah, sorry. Yeah, it's pretty much. But the main idea was this also first in this pet VM approach, or was this really done by using a different approach? Or
you mean at DataCamp?
Yes, or yeah.
it's hard for me to say, to be honest. You should ask the guys at DataCamp. I don't know, to be honest. Yeah.
But guessing at what a scale they run, they can't run everything on one VM. So they'll probably have automation for all the notebooks and courses they run to automatically spin up stuff.
I would guess so. At this, maybe they started that way, right? Maybe they started with 3 massive VMs and pull all the students through that. I don't know. But if they did, you probably can talk to their CTO and he will complain about all the pain he's felt with pet VMs and why they moved away from it. I'm pretty sure that would be the story.
Yeah, I was fishing for such a story with you, actually. So it would be nice to hear.
All right. Yeah, so then we move to the high feasibility, low effectiveness options. And one of them is, and we see that a lot actually, is that you just run your analytics on your laptop. Once you found your insights, you copy your insights to somewhere. Yeah, what's nice about that, it's still relatively easy to do and you have full control over your own tooling. I can install on my laptop whatever I want. So I need to calculate something once, I update it to a drive somewhere and I'm done. But of course, it's hard to scale to multiple people. If I'm gone now, somebody else needs to run that. And how did Kris run that again? I don't know. I can't reproduce it. It's limited by the capacity of my laptop, of course. There are some security issues with that because why can I directly connect to a production environment? Shouldn't there be some gates in between me and the production? Your laptop is obviously a single point of failure. It's very error prone and it's not auditable. So if you quickly want to test something out, like, hey, let's do a churn prediction and let's put that churn prediction in a database and see, and let's run with it and see what happens, I'm fine. But of course, you can't have copy from laptop as part of your production workflow, right? So you need to remove that as soon as your product moves out of MVP stage. This is also something we see a lot, way more than we like, actually. It's just running on a notebook in the cloud. So you open a cloud notebook, that notebook has connection to your production data. You build your pipelines right then and there. Once you're done building, you typically have like a set of notebooks with like hundreds of cells. They all depend on each other. You schedule your notebook and then you just wait for a few days, a few weeks, and you start crying while you do support on that thing. The good thing is, again, it's relatively easy to do. Everybody can open a notebook and start hacking. A notebook in the cloud can scale. Multiple people can work on the same notebook, so that's nice. Again, that's also a con, because if multiple people work on the same notebook, who changed what, when, where, you have no clue. There's no version control, there's poor error handling, there's poor testing. You get a lot of spaghetti code in my experience. There's no modularity, there's no functions, there's no abstractions, there's nothing. And there's also very limited visibility of what is actually in production. So again, these are one of these things that it's appealing to get started with, and for an MVP, just hack your way around the notebook. By the way, if you're a data scientist and you want to do discovery or like learn about models, go for it. Use a notebook. As part of a production system, we've never seen this go right unless you start automating a notebook, and that's something that Stijn will discuss later. Now, some of you might be thinking, well, Kris, that's obvious, nobody would do that, but that's not really true. As one example of just to show you how prevalent this is, if you ask like Microsoft, like what is your typical modern data platform, they will put a bunch of Azure components, and somewhere in the middle they will say, hey, you need to do your data prep and your data training, your model training. You need to do that in a Databricks notebook. And that's something actually when we go to new clients, we always need to spend some time explaining, look, yes, it's easy. Yes, you're going to get started with this, but it will bite you in the long run. So it's something we see coming back a lot. I don't know how it's like in your organizations, but yeah, we've often had to deal with this, and it's always a pain. So that is it for the, let's say, what we call low effective options. So they might be feasible or not, but they're not very effective. I'm going to switch to Stijn, who will explain some of the high effective options. Go, Stijn.
Is that because I'm highly effective, Kris?
Yeah, because you're smarter than me and you know all of this.
Okay, let's start with the first automation that people did. It's called kettle VMs. And what's the big difference between a pet VM and a kettle VM? You don't care if a kettle VM dies. You just spin up a new one with the same configuration. Or you spin up 10 new ones with the same configuration, with the same installation. So what this means is that you automate the building and the deploying of your VMs. So you don't actually care if one dies, it just spins up a new one, sometimes automatically. On AWS, you can, for example, have auto-scaling groups. And if one of your VMs dies, it will just spin up a new one automatically. This means you also automate the deploy of a VM. That means that you have somewhere a script that just says apt-get install Python, pip install Jupyter or Airflow or something. Also configures all your config files automatically. And then you can just spin up 10 VMs with that exact same configuration.
Yeah.
This was one of the first ways to automate your infrastructure.
Yeah, if you look, for example, at DataMinded 6 years ago, when PaaS was a lot less prevalent than now, this was our default way of doing things. We would create AMIs with Packer, then we would deploy those AMIs with Terraform or with Ansible, I forgot. And then we would script what's in those AMIs. I forgot what it was again. So it was a mix of technologies. But once it was deployed, like, it was hard to learn, but once it was deployed, it was super. Like, some of these architectures that ran for years, like, without us needing to touch them. And if one of those VMs went down, a new VM would be created. It was really cool. Yeah.
This is the proper way to use infrastructure as a service and build your own PaaS platform on top of it, actually. It's also what internally the cloud providers do, right? They build AMI, they build VM packages that they deploy on tens of machines to have EMR running, for example. And the pros is your infrastructure is automated and you can destroy a VM and bring it back again in minutes. So that's nice. But you still have to do a lot of the infrastructure automation yourself. So you still only have VMs. You don't have higher level constructs. You need to build those yourselves. So if you want to make a Hadoop cluster, for example, you need to orchestrate creating the Hadoop masters, the Hadoop slaves, and all those kinds of things. And a VM is still a big resource. It's way, you can start up a VM with 4 CPUs and then only use 10% of it. So a lot of resources can go to waste. And yeah, it's a very low level building block, but it's the basis of everything.
All right.
Then to automated notebooks. What is it? You run your notebooks on a schedule, but you do it in a scalable way. And I think one of the most prevalent examples of this is Netflix. One of the big pros of this is that notebooks are easy to understand. So you can have data scientists use this. Your data and software engineers also use this. And you can also let business schedule SQL queries in these notebooks, for example. So everybody can work with the same technology, and that's a pro. And notebooks are also a good artifact of a run. What do I mean by that? You have your cells, and each of your cells has an output of what has happened for a certain function. And that is a good way to see if one of the cells went wrong. If you store that as a format, you can easily debug, this step went wrong, this was the error. So it's actually a good log of a run of your software. However, to do it properly, it's pretty complex. And it's mostly only good for batch systems, or it's very early stage for doing it in streaming services. If you go to the next slide, we can zoom in on the Netflix architecture. So at the top left, you see they built their own notebook UI to start with. So that's already good for them, I guess. At the middle top, they built interactive compute using Jupyter servers. So most of the time, you can have something like this in the cloud automatically that starts a notebook. And yeah, then they just do exploration. But they also allow, with their scheduler at the bottom left, called Mason, they allow you to template your notebooks. So for example, they can reuse the same notebook to process different tables of a database roughly the same way and ship them somewhere. So that's for them very interesting. And they also built their own scheduled compute thing for then running these parameterized notebooks.
And by the way, this is typically one of the discussions we have at clients when we look at their current notebooks, which are all spaghetti code and they have zero automation and it's poor. And then we start having the argument like, hey, maybe you should move out of notebooks. And then, but the counter argument is, yeah, Kris, but what if we start extracting the code, we start using libraries, we start adding a scheduler, we start adding all those things that Netflix has done. Can't we use notebooks then? Well, the answer is yes, of course. That would be a very highly effective way of deploying analytics workloads to production. But I do think that like not everybody in this call has the same budget as Netflix. I think nobody here has the same budget as Netflix. Don't underestimate the complexity of building this thing, right? I mean, this is not something that you can build on a Friday afternoon, or just even like, let's focus this summer on building this, and then as of September, we're good to go. No, this is a lot more complexity than people see when they get the idea, I would say.
Yeah. Also, when you do this at Netflix, they highly recommend you to, if your notebook gets very complex, they even automatically pop up a notification, hey, maybe you should extract this in a library. This is the pattern we use. And then instead of just having all your code in a notebook, they recommend you to build a library with unit tests, with maybe integration tests if you want. And then in your notebook, you just call the functions of your library. So the notebook is more the orchestration in which order you have to run functions of your library in that way, and offers you a way to see, hey, this function has this as output, and then you get that result.
Right.
So it's typically it's pretty complex, and they also they don't code in notebooks the whole time.
Okay.
We've gotten 2 questions out of the audience.
All right.
How is it different from the combination of Azure Data Factory and parameterized Databricks notebooks? Yeah, it's roughly similar. I think that, I haven't used it, but the ideas are roughly similar, except that the thing they recommend at Netflix is as soon as your notebook gets complex, make code out of it. And I guess you could do that with Databricks notebooks as well. Yeah,
I haven't seen the setup that they've done there, but if you only take like those 2 components, like Data Factory and Databricks notebooks, basically you get an interactive compute and a scheduler, right? You don't get any of these other components. So do you have a deployment mechanism, or do you have like this mechanism to promote something from development to prod, something like that? Do you have a way to test your code? Where do your logs go? Do you aggregate your logs somewhere? Do you offer monitoring services? So again, right, I'm not saying you can't do it, but in the clients we've seen, we haven't seen things being set up in a way that really, how do you say, was very helpful for the operational part, for keeping this alive.
But it might be that those 2 are good building blocks to do this. You just have to still go the extra mile and make it proper.
Yeah, I think definitely if you're on Azure, I think integrating the Azure Data Factory with this is step 1. But in our opinion, right? So what do we know? But in our opinion, we sometimes feel, or I sometimes feel, that it's being oversold. If you go back a couple of months later to those teams, we see them struggling with keeping their things operational, because that's in the end, that's the goal. It's not, the goal is not to have a deployment. The goal is to have a stable deployment that you don't have to spend time on later, coming back, fixing stuff and operating on all the time. And we haven't seen that a lot if you do notebook-based deploys.
And Pascal had another question. Can the notebooks be seen as the final frontier, which then gets converted to the civilized world? I'm not sure what you mean by that, to be honest.
Yeah, maybe just so the way that you guys explained it, and also the way that apparently Netflix seems to incentivize people, is once it becomes too complex, turn it into a library, which kind of feels like with Jupyter Notebooks, you can quickly push forward and discover the right way. But then once you want to have it persistent and consistent and, like you said, maintainable, that reminds me very much of this like final frontier during the exploration of the US. And then you kind of convert it into a civilized environment where everything follows patterns and structures.
Oh, that I can definitely recommend. I do that myself all the time. When I'm into something new and I have no clue what I'm doing, I always open a Jupyter Notebook and start hacking away. But indeed, that's like in the early stages of discovery. And once I know what I'm doing, I'm abstracting things in functions. I'm writing tests for those functions. I'm packaging everything. So that way of working, I can only recommend. Like I am to be clear, I'm a big believer of notebooks in that phase, right? I think it's hard to do any analytics without a notebook these days. So just don't schedule your notebooks in production.
I think we'll need to go to the next slide.
Yeah. Just to be wary of time. Okay, go for it, Stijn.
I'll try to do this faster. So another option is Docker and Kubernetes. Kubernetes is a container platform that allows you to build platforms at scale. Why do I say build platforms at scale? Because I think giving people direct access to Kubernetes is a bit too low level still. It's born in 2014 out of Google. This is their third iteration on such a platform, but this time in open source. And I think it's a very good building block for your data platform. See it as a better cloud abstraction that can be reused across clouds. And it has a very large and growing ecosystem. Also, the nice thing about Kubernetes is that most of the software that comes out or that is already out integrates or is integrating with Kubernetes. For example, Spark, Airflow, and there's a lot of others. I think Flink also has a way to run on Kubernetes, for example. It's probably the platform of the future. I'm 90% sure at this point. And it offers you very fast startup for your applications and very rapid feedback if you're using it, which is very nice. Spinning up a container is always faster than spinning up a VM. Cons, we're not there yet. So a lot of software is in the transition of supporting Kubernetes, or the support has just been started and it's not super mature. And it's a good building block, but you need a deep knowledge of Kubernetes. And it's rapidly changing. Like they do minor releases. That's the minor version number every 3 months. And the big changes have kind of stopped, but on the edge of Kubernetes, the core is stable, but the edge is still changing constantly. And it's very hard to find people with hands-on Kubernetes knowledge on the market. So you'll probably be learning all of these things from scratch.
Yep.
And a typical example of software that we use on a Kubernetes cluster is, for example, Airflow that can horizontally scale on Kubernetes, so it's very well integrated. And we also use Spark on Kubernetes then to trigger batch jobs. And for things that aren't Spark, we just trigger containers that run on Kubernetes. So that way we can easily do an FTP ingest, for example. That's just a Python script that takes files from an FTP and copies them to a file store somewhere for later then processing via Spark. And the nice thing is that we can use the same Kubernetes cluster to do our real-time operations. So we don't need to maintain 2 clusters, for example, that we use a Yarn cluster for all our Spark jobs. And then we use a completely different cluster to run Flink or something on top of it. So that's nice.
All right.
Another option that we wholeheartedly recommend. So now we're in the high feasibility, high effectiveness. Is using container/jar platform as a service APIs, and we've added some examples of AWS with AWS ECS and EMR, and Azure AD Insight and Batch. These are ways to run containers or jars managed by your cloud vendor. So these are not basic building blocks anymore. These are very high-level building blocks. You just tell it to run this container or run this jar, and it will run it for you. You still have a lot to tweak sometimes, but most of the complex work is done for you. These are very stable and mature technologies most of the time. They can be used at scale, so they can scale across multiple teams. And most of the time, metrics, monitoring, logging is all well integrated in the cloud. So you don't need to do that. Cons, sometimes not everything comes out of the box, and also some things you just can't tweak. Like they pick some settings for you sometimes, or if they for some reason like sending logs somewhere isn't ready yet, you can't change anything, right? They offer it as a service, and you still need a lot of glue to get these services hooked together. a lot. It's already less than building straight from VMs, of course. And you have some vendor locking on these specific building blocks. However, actually, you see that you have EMR on AWS, you have HADE Insight on Azure, you have Google Data Proc, I believe, on Google Cloud. So each of the clouds have roughly the same service on each of the clouds, so it's not a real problem. And sometimes not everything is automatically set up. That depends on how mature each of the components is.
Indeed. Maybe switch to the example.
Yeah. So this is an example of a typical example that we do. So we use AWS Code Build for our CI/CD to build jars and Docker containers. And that then we tell Airflow, you need to run this version of the application right now. Airflow isn't available as a service on AWS, so we installed it with a Kettle VM on EC2. And then we just trigger AWS batch jobs for generic Docker containers or very small Spark jobs that can run on one machine. And we use EMR for the big jobs, and we just spin up an EMR cluster on the fly. We launch some applications on top of it, and we break it down again.
And that's something that if some of you in the call still remember the days when we did things on premise, and I was working on on-premise Hadoop cluster and was complex, and then I remember the first time I saw the AWS EMR command, just create a cluster for me. This should be the size, and then run this jar in the cluster and shut yourself down again. Thank you very much. That was like 5 lines of code or something, and I was like, whoa, that's like 2 weeks of work, all like compacted down to 5 lines of code. It would take 15 minutes to spin up. It would run. It would shut itself down. And it's, the step it brings from like your on-premise clusters to these PaaS services in the cloud. It's amazing acceleration and speed you get there. Maybe what we can also add there. This is an AWS example, but if you look at how we would do this on Azure or really on Google Cloud or any cloud, it's almost exactly the same. It's just you use the Azure native services. So we don't use Amazon Cloud Build. We use Azure DevOps. We still push to Airflow, but we run Airflow on Azure App Service because it's very nice use case for that. And then we either trigger jobs on Azure Batch, which we're big fans of Azure Batch. We think it's a really nice system. Or for larger jobs, we send them to Azure AG Insight. But to be honest, like the kind of VMs you can schedule with Azure Batch, like with 500 gigabytes of RAM or more, like there's not a lot of reason anymore to go for cluster compute if you can just run it on a batch compute, like on a single node as well. So yeah, this is all to say, yes, your architecture will look different on Amazon than on Azure or on Google Cloud, but it's not that complicated to migrate away from one to the other, right?
And the same IDs work for every cloud. Like they have roughly the similar services. Sometimes they offer something completely different, like Google BigQuery versus Amazon Redshift. It's the same ID, but the pricing model is completely different.
Indeed. And then the final option we wanted to discuss is to use frameworks, and we consider the frameworks to be highly effective and highly feasible. So why a framework? Well, there's quite a lot of people in this call. There was quite a lot of interest in this webinar. Why? Is because that's a recurring problem. Everybody has struggles with their deployment mechanisms. So there are some patterns emerging. There's some frameworks emerging, and they help you automate to the production grade deployment of your code. So a few examples there is in the web world is Netlify. You have serverless.com for serverless deployments, and our very own Datafy that Stijn will demo. We also aim to solve that in the exact same way as the other ones with a framework. So what are the pros of using a framework is that most of the complex work is done for you. You just follow industry best practices. You don't need to worry about anything. Monitoring comes out of the box, scaling comes out of the box. You're up and running in no time. It's really cool. What you do need to be aware of, like whatever framework you pick, the framework is always tailored to specific needs, right? You can't just say, hey, I like serverless.com. I'm going to like all the things I'm going to do for the next 10 years. I'm going to adapt to the serverless.com framework. That doesn't make any sense. So you're always going to be a bit constrained to what the framework offers. A demo of this, I'm going to try to do this live. Let's hope to the demo gods that it works. But that serverless framework, so I hope you all see my shell now. Can I zoom this in? If you, I have no clue. Bigger? Command plus.
Command. Yeah.
Yeah. Yeah, like this. If you just do serverless init and you pause in some kind of GitHub repo, you say init AWS Python demo, it's downloading and installing this thing. And now if you see it created a folder for me, AWS Python demo. If I go in that folder, you see it created like a handler.py, a package.json, a serverless. We're not going to explain everything you see here, but if you quickly just open the handler.py, and now you, by the way, you see I'm not a Vim guy. I have no clue. I can barely exit Vim. But if you go in Nano and you say, okay, this is a function I want to execute. So I say, hello, webinar users. I close this thing down again, and now I say serverless deploy. That's it. That's all I need to do. And this, the first time I saw this, what it will do behind the scenes, by the way, is I've created a Python function, handler.py, that does some custom logic for me. It could be loading a machine learning model and scoring it. It could be doing some transformation. It could be whatever. It will package it up in a Python package. It will send that package to the cloud. It will deploy it on AWS Lambda. It will also create an API gateway for me. And while I'm talking, it's done, actually. It has created this API endpoint. It's HTTPS by default. And if I curl that endpoint, what do I get? It's a hello, webinar users. And this thing is live. This is live. I haven't cheated. Like it takes me longer to explain than to actually do. Now I have an API endpoint that tried to DDoS this thing. It's impossible. Like it's live. It's available. It's secure. And it's not a static page either. I can do my logic behind the scenes. And the first time I saw this, I was almost insulted. I was like, what the hell? You used to spend days or weeks to really get to deploy an API that is stable and scalable and accessible and whatnot. And now it's literally 2 lines of code. So definitely, if you're in the serverless world, if you have use cases to access data through an API or to connect to a website or whatever, definitely look at serverless.com because it's really cool. Oh, yeah. So next slide was just in case my 3-line demo would crash. Here's the demo again. So let's recap what we've seen, right? Because we've given you a lot of information. Come back to this 2x2 matrix. We score deployment mechanisms by feasibility and effectiveness, where obviously we want to go for the highly feasible, highly effective options. We looked at things that we don't want to do, like pet VMs. Stay away from that as much as you can. Run on a laptop and copy, or using notebooks. It's fine to get going, to get started, but you'll often run into constraints. I hope that made sense as well. Finally, if you have a mature team, if you have strong DevOps skills, you can look at more advanced technologies like Docker, Kubernetes, automated notebooks, Kettle VMs. And by the way, this is like something that if you can't figure that out yourself, you can hire companies like DataMinded to do this for you. So I should actually be promoting this more and say, hey, everybody should do this, and then you get stuck and then we come and help you. But actually, we do believe it's not an ideal option. Why? Is because it's not super feasible for a typical data team, and we would much rather focus our time and your time on something that creates value for your customers or for your business. And that's why try to use as much as possible the PaaS APIs that come with the cloud providers out of the box natively. They take a lot of the complexity away for you. And as a next level, look at these off-the-shelf frameworks that literally turn a deployment into 2 lines of code. All right, so I hope that makes sense. Maybe I'll pause here. Are there any questions before we go to the next section? We're almost out of time, to be honest. Maybe, Stijn, it would be useful if you quickly demo how we do this at Datafy as well, and then we have a few more minutes for questions.
Yeah. I'm presenting my screen. Do you see it?
Yeah.
Okay.
Yes, I see your screen.
So we're in a project that Kris created. So don't look at the code, I would say. So we have an open air quality project. It's based on the open air quality. It's a PySpark project. It has code, some tests. It is packaged, in this case, in a Docker file. We have an automatic, this is from our templates. This is an automatic generated README. I don't believe Kris has written this. And we also have a generated DAG that allows you to run this, that uses our Datafy Spark Smith operator to run this Spark job. So very much like the serverless framework, we provide you with an example. If you create a new project, we provide you with an example on how to start, and you can start from there. And then if you want to deploy that example, you first make a build with the Datafy project build command. And that just builds your Docker container, pushes it to the cloud. I've already pushed it, so we don't have to wait for this Docker container to be pushed. Now we can see we have our project here. You can see which other projects are in our cloud. And at the moment, I think we have 4 of them, apparently. We can also see environments that we have deployed already or created already. We have a dev environment and a test environment. And to deploy our project to a test environment, we can do, I'm correct, yeah, deploy min fdev. And this deploys it to our development environment. And so we have 2 big concepts, environments and projects. And in an environment, you can easily see which projects are deployed on there. You can also see what is going on. So we're right now doing a deploy. It's just notifying us of what it's doing. And we can see the airflow that is linked to that environment straight from the UI. So this is our project. It was already deployed. It has been running successfully for a couple of days. So it's as easy as that. We create a project from a template, and then we can easily deploy that to an environment.
And then maybe to make the comparison with serverless.com, there's a lot going on behind the scenes here. Like we run that Kubernetes cluster, we deploy things to a Kubernetes cluster, we link monitoring for you, we provide the web UI. And these are one of these things that, yes, you can do all of that yourself. Like you don't need to use serverless.com, you don't need to use a Datafy, but you're going to spend a lot of time creating those and getting those stable. And it makes a lot more sense. Like that's not going to be your core business value add to your organizations to have a good deployment. It makes a lot of sense to just take that off the shelf for someone who provides it for you. So theoretically, I think it takes 2 minutes to deploy something. So you can, like using a framework like Datafy, you can deploy to your environment like 720 times a day or something, right? So you can definitely get to the 10 deploys a day if you want to.
Yeah.
All right.
I think you can take over the presentation again now.
Yeah, I see we run out of time, so sorry for that. We did a poor timing job here, but I think what we saw here is a bunch of screenshots. I'm just going to go back to the conclusion. So to recap what the webinar was about, we honestly believe that webinars are the most important thing you do, because you can only create client impact when your code runs in production. Everything before that is work in progress. Aim to do it as fast as possible, and a good yardstick is, can I deploy 10 times a day per team? The more often you deploy, the more often you can learn from your customer. So it's really something you should try to accelerate. And then in order to get that acceleration, look at off-the-shelf frameworks, look at platform as a service APIs. And only when you get into limitations of those, look into what should we build ourselves and which kind of budget do we have available to build it ourselves. And with that, I think we're more or less done. I think we said what we wanted to say. We have a few more minutes for questions. So if anybody has a question, I would say shoot.